Hey everyone, I'm going to tell you today about machine learning APIs by example. I'm going to show you how you can access pre-trained machine learning models with a single API call. As Jeff mentioned, my name is Sara Robinson, and you can find me on Twitter at srobtweets. I'm a developer advocate on the Google Cloud Platform team based in New York, not too far away from Boston. As a developer advocate, my job is to build demos, showing developers like you what you can do with different Google Cloud products. I focus on machine learning and big data. I also do talks at events and write technical content and blog posts. So let's get started by talking about, at a high level, what is machine learning? So machine learning is essentially teaching computers to recognize patterns in the same way that our brains do. So it's easy for a child to differentiate a picture between a picture of a cat or a dog, but it's much, much more difficult to teach a computer to be able to do the same thing. So the idea here is that as we give our machine learning models more and more training data, as we give them examples, they'll improve over time with experience and be able to make generalizations, identifying different things. So here we have a neural network that identifies a picture as either a picture of a cat or a dog. And we can think of the input to this network as pixels, and then the output, the label, is going to be a prediction. Is it either a cat or a dog? And each of these layers in the network is looking at different features that it identifies through the pixels in the image. Maybe it's the shape of the ears, the eyes, the nose, etc. And then its final output layer is a prediction. Well, let's take a step back for a moment and say we didn't have any neural networks. Let's try some human-powered image detection. So if we were to write an algorithm to differentiate between these two pictures as either an apple or an orange, what are some things we might look for? Since I can't hear you, I'm going to assume that someone's going to shout out color. So if we looked for color, we could say, okay, are the majority of the pixels in the image red? If so, it's an apple. Otherwise, it's an orange. So that would work really well in this example. But then what would happen if we had grayscale images? Then we'd have to start all over again. In this case, we might want to look for something like texture, or is there a stem? And that would work pretty well for this example. But then what if we got crazy and added a third fruit? What if we added a mango to the mix? Then we would have to write our algorithm all over again. Now, all of these images are pretty similar. They're all different fruits. They're all relatively circular. So this image classification task should be a lot simpler if we have two images that look nothing alike, right? So what if we have a picture of a dog and a mop? These two things have pretty much nothing in common. The mop is not alive. It doesn't have an eyes, nose, or ears. So this should be pretty easy to do. It's actually kind of difficult. So here we have pictures of sheepdogs and mops. We've got 4 sheepdogs and 4 mops, and it's kind of hard to tell the difference. So the point here is that we don't want to write specific rules to identify each individual thing in our images. We want to write code that will find these rules for us and recognize these patterns. Because what if we don't just have pictures of people and dogs and mops and fruit? What if we have photos of everything? And in addition to photos, we might have other types of unstructured data as well, like video, audio, and text. So what I want to talk to you about today is how Google Cloud can help you make sense of this unstructured data through machine learning. And there's essentially 2 ways to do this on Google Cloud. So on the left-hand side of the slide here, you can use TensorFlow, which is an open source framework, to build and train your own custom models using your own data. And you can run TensorFlow on any cloud. Cloud Machine Learning Engine is a product we offer that lets you run, train, and serve your TensorFlow models on managed Google infrastructure. So both of these things require some machine learning expertise. And then on the right-hand side, which is where I'm going to focus today, is what I like to call friendly machine learning. So these are 5 APIs that let you access pre-trained machine learning models with just a single API call. So all you need to know how to do is make a REST API request. You can start benefiting from some machine learning functionality. So I'm going to give you an overview of each of these APIs. We're going to do some fun demos. So I will dive right in, starting with the Vision API. And the Vision API lets you do complex image detection with a simple REST request. And before I get into the details, for each API, I want to tell you a little bit about 2 customer examples of people that are using these APIs. So for the Vision API, on the left-hand side, the first example we have is Disney. They use the Vision API to build a game for a movie called Pete's Dragon, which they wanted to promote. And the game essentially gave users a scavenger hunt quest. They were given a clue, and they had to take a picture of that item. Could be couch, chair, computer, etc. And if they successfully took a picture of the item in the quest, they would the app would superimpose this image of the dragon in the image. So they needed a way to verify that the user actually took a picture of what they needed to for that particular part of the quest. And the Vision API was a great fit for this because they could just send the image to the Vision API, say, okay, does this image contain a couch? If so, they got it correct, and then they get some points in the game. And then my other example on the right-hand side is Realtor.com, which is a real estate listing service. And they are using the Vision API's optical character recognition feature, their OCR, so that when people are out and about in a neighborhood looking at houses, they can go to the Realtor.com iOS or Android app, take a picture of the listing with their phone, and then the app will bring up the relevant listing by extracting the text from that image using the Vision API's OCR. So those are two examples of the Vision API in the wild. And now I'm going to talk about what you can do with the Vision API. So here are 6 core features of the API. The first feature we can see in the top left is label detection. So this is essentially, what is this a picture of? It'll return different labels. Like in this example, it might return cheetah, animal, field, and it'll return a confidence score for each of those labels of how sure it is that it correctly identified the object in the image. Face detection will tell you how many faces are in the image, where those faces are, and what emotions can it find in the face. Is the face happy or sad, angry or surprised? And then we have OCR, which was the Realtor.com use case that I just mentioned. This can identify text in an image. It can also tell you what language the text is in, and it can identify where in that image the text is. So this is using something similar. If anyone's ever used the Google Translate app and taken a picture and seen the live translations, this model is using something similar to that. And then we have explicit content detection, which is pretty self-explanatory. This will tell you, is this image appropriate or not? And this is actually really useful for any sort of app that has user-generated content. So rather than having somebody manually flagging images as is inappropriate, you can just make an API call, and then you only have to review a subset of your images that may potentially be inappropriate. Then we have landmark detection, which will tell you, is there a common landmark in this image? What are the latitude, longitude coordinates of that landmark? So this would say this is a picture of the Eiffel Tower. And then finally, we have logo detection, which can identify common company logos in an image. So I wanted to show you a little bit about the JSON response you get back for a few of these different features. Here we have for face detection. So this is a selfie that I took with 2 of my teammates on a trip to Petra in Jordan. And it returns an object for each face in the image. Here we just see the JSON response for my face in the image. And it says headwear likelihood is very unlikely, which is true. I'm not wearing a hat. And we can see that joy likelihood is very likely. I'm smiling in the picture. And we get a bunch of other details with the image too. We can see surprise likelihood. We can see where different features are in the face. It tells me where my left eye, right eye is. Some of this is clipped here. And then we can also see sorrow likelihood, blurred likelihood. There's a lot more data that you get back. So that's what face detection looks like. And then here is an example of landmark detection. So here's a picture of the Eiffel Tower, right? Everybody knows what this is. It is actually not the Eiffel Tower. It is the Paris Hotel and Casino in Las Vegas. And I wanted to see, can the Vision API spot the difference? And turns out it can. So this is what we get back from landmark annotations. We get this MID, which is an ID in Google's knowledge graph. So you can call the knowledge graph API if you want to get more details on this entity. We get the name as Paris Hotel and Casino, the confidence score, and then we get a bounding box of where it found that landmark in the image, along with the latitude and longitude of that landmark. Forgot to update this slide. So these features have been around for a couple weeks now, but these are some newer features to the Vision API. One of them is crop hints. which will give you suggested crop dimensions for your photos. Web annotations is my favorite of these newer features. I'm going to show you a little bit more about that on the next slide. It lets you search the internet for more details on your image. And then document text annotations provides improved OCR. So if you take a picture of an image with a lot of text in it, maybe you take a picture of a document like a resume or a business card, the model will do a better job of identifying at a granular level all the text in the image, breaking it down by lines, paragraphs, and words. Just to show you how the web annotations endpoint works, I have this image of a car, and it's not just any car. It's a car that's on display in a museum, and I'm actually a big Harry Potter fan, so this is the car used in one of the Harry Potter movies, and it's on display in the museum. So I sent it to the web annotations endpoint and wanted to see what entities it found in the image. So the first one it found was a Ford Anglia, which is true. This is indeed the correct model of this car. And it does this by looking at the context of the page where this image is found. And it also tells us Art Science Museum, which is the museum in Singapore where this car is currently on display. And finally, it tells us that the car is from Harry Potter, which is a literary series. So these are the web entities that we get back. We also get back a couple more pieces of data from the web annotations endpoint. So we get the URLs of all the URLs across the web where this exact image exists. We also get the URLs of similar images. That's what this partial matching images response is. And then we get any pages, the full page URL of any pages that contain this image. So again, just a single API call, we get back a ton of metadata on this image. You can all try the Vision API in the browser with your own images. If you go to cloud.google.com/vision, before you write any code, you can upload your images and see all the different details of the response that you get back. And in case you were wondering, back to our sheepdog versus mop example, this is how the Vision API performed on some of these images. So if we look at that picture of the dog all the way to the right, this is the response we get back from the Vision API. It's 99% sure that it's a dog, and we notice here it's even 77% sure that it's a Commodore, which is the breed of dog that this is. If we look at our mops, it identifies this as a broom or a tool. I'm not going to show you each individual response, but it did pretty well overall on all the images. So for the dogs, it was able to identify 3 of the 4 as a dog. This one just said fur, it didn't say dog, so wasn't sure if that was a hit or a miss. And for the mops, it identified all of them correctly, except for this one, it said textile. So overall, this pre-trained API is able to do a pretty good job at identifying things that are even hard for the human eye to differentiate between. So that was the Vision API. Talks about how you can analyze your image data with a single API request. And now I'm going to talk about the Speech API. And the Speech API essentially exposes the functionality of OK Google to developers so that you can implement speech recognition in your own applications. The Speech API lets you do speech-to-text transcription in over 80 languages. An example of an app that's using it is this app called Azar, which has connected over 15 million matches. And the way that they're using the Speech API is to transcribe any audio messages that are sent between matches. And there's also a lot of potential use cases where you can combine multiple cloud machine learning APIs. So in cases where the 2 matches don't speak the same language, they'll use the Speech API to transcribe it, and then they'll use the Translation API to translate the text into the other user's host language. So the best way to see how the Speech API works is through a demo. And in this demo, I wrote a bash script that's going to make a recording using SOX, which is just a command line utility for recording audio. And then we'll create our API request in a JSON file. We'll send it to the Speech API, and then we'll receive the response. So I'm going to go over here to my terminal. I'm hoping everyone can see it. I can't hear you, so I hope that you can. And I'm going to call my script, bash request.sh. And it's going to say press enter when you're ready to record. So I'm just going to record a 5-second audio file. Here I go. I am excited to be presenting at the Boston AI Meetup from New York. So I'm going to send that to the speech API now. And if we look here, we can see what the JSON request looks like for my audio snippet. And we can see it did a pretty good job. It didn't get the AI acronym, but it did essentially get everything that I said there. And it is 92% confident in its transcription. So here we just need to tell the API the encoding type of our audio. Here we're using FLAC encoding, the sample rate in Hertz, the language code, which will default to English. And if you want to do a transcription in any other language, you just need to pass it the language code of whichever language your audio is in. And then using the speech context parameter here, you can pass it phrases that you might want to look for, but that might not be immediately recognizable. So say you have like some proper noun or some very industry specific jargon that people might be saying in your audio. You can give it some hints of phrases to look out for so that it can correctly identify those proper nouns or terms. So that is the speech API. I'm going to go back to my slides. And next thing I want to talk about is the natural language API. So we just talked about audio. So once you transcribe audio, you've got text. You might want to do some further analysis with that text. So you might want to analyze, the sentiment, extract entities, or do some linguistic analysis of your text. And that's what the natural language API can help you do. One company that's using the NL API is Wootrick, and they are a customer feedback platform that help their customers. Their customers are companies that are trying to make sense of customer feedback on their apps. So to give you a little bit more detail about what they do, if you've ever been on a site and seen a form that looks something like this, Wootrick is a company that powers that form, and they ask people to say, how is your experience in this app? And they rate it from 0 to 10. And then they ask people to provide additional open-ended feedback. So the numbered score is pretty easy for them to make sense of. What's much more difficult is to help their customers make sense of this open-ended feedback that they're getting. And to do that, they're actually using all three methods of the natural language API. They're using sentiment analysis to say, okay, did the user's open-ended feedback align with the score that they gave? Let's say they gave it a 9, but it looks like they actually might not be very happy with the app after all. Then they use entity analysis to extract common entities from the text, to get the topic of it. And then they can use the syntax analysis feature, and I'll talk about all of these momentarily, to see how people are describing different topics. And this has allowed them to route and respond to feedback in near real time, instead of having somebody have to manually look at all of this open-ended feedback and route it. So they could say, here's a customer that is angry about usability. Let's route them to the right person. So let's look at each of these methods in detail. First, I want to start with the entity extraction method. So I have this sentence about J.K. Rowling that I took from her Wikipedia page, and I wanted to send it to the entity extraction endpoint, and it returned these 5 things as entities. And if we inspect the JSON response we get for these entities, we'll notice here that the first 3 entities all refer to J.K. Rowling, the same person. Robert Galbraith is just a pen name she used. And the API is able to normalize all of these and point them to the same entity, same Wikipedia URL. So we get back her name, the type of entity is person. We get some metadata about her. We get the MID to the entity for J.K. Rowling in Google's knowledge graph and her Wikipedia page. For British, we get location. If this instead had said United Kingdom, it would map to the same Wikipedia page we see here, United Kingdom. And Harry Potter is a person, and it goes to the Wikipedia page for Harry Potter. So that's what the entity extraction endpoint will give us. And it also returns entities for things that may not have a Wikipedia page. So if it instead said Sarah Robinson, it would return me as an entity, even though I don't have a Wikipedia page yet. So the next thing you can do with the API is sentiment analysis. This is pretty self-explanatory. So if I gave it this sentence of the food was terrible, I will not be going back. If I worked at this restaurant and saw this review, this is probably something I'd potentially want to flag and maybe follow up with the customer. But I might not want to have to read through every single review that I got. And so the API returns 2 things here. It returns a score, which is just a value from -1 to 1, saying how positive or negative is the sentiment in this sentence. Here we see it's almost fully negative at -0.9. And then magnitude is a number from 0 to infinity, telling you, regardless of being positive or negative, how strong is the sentiment in this text. So here we get 0.9, which is pretty small because we just have a sentence with a couple of words. We recently added a feature that lets you do entity-based sentiment. So I'm going to hop on over here to the browser. This is just the product page for Natural Language API. I'll share the link at the end. And there's a try it box down here, which lets you enter anything and see the response from the API. So I'm going to enter something to show you the entity-based sentiment. So I'm going to say, I'm writing a restaurant review. I'm going to say, I liked the sushi, but the service was terrible. And I'm going to analyze it. And we can see that for sushi, I got a sentiment score of 0.9. And for service, I got a sentiment score of -0.9. Because in this, if I got this review, the overall sentiment score wouldn't be very useful to me. I might want to see, break it down and see which things, how people thought about each individual item in this text. So we can also see the overall document sentiment here, and we get this dependency parse tree, which I'm going to talk about momentarily. But all of our APIs have this page where you can enter your own text, record your own audio, and kind of inspect the response in the browser before you write any code. So I'm going to go back to the slides. And as you briefly just saw, the third method that the Natural Language API provides is syntax analysis, which gets more into the linguistic details of the text that you're sending it. So here I have the sentence, the Natural Language API helps us understand text. And I get a couple things back here. I get in green, this is called a dependency parse tree. It tells you how each of the words in a sentence relate to each other, which words depend on other words. In orange, I have the parse label, which tells me the role of each word in the sentence. So helps is the root verb, API is the nominal subject, us is also a nominal subject. And then I also get the lemma. I just have this for help. So the lemma is essentially just the canonical form of the word. So for helps, it would be help. If this instead said understands, it would be understand. So this is useful if you're counting how many times a particular word is used to describe something. You probably only want to count the lemma form of the word so that you don't get different tense variations. Then we get the part of speech. Is it a noun, a verb, or a pronoun? And we get some additional morphology details on each token in the sentence. And again, as you saw before, you can go to the Natural Language product page and generate these diagrams for whatever text you'd like. So I'm going to show you a demo, which specifically focuses on syntax annotation, which was that last feature I showed you. And what I did here is I wrote a node server that streams tweets using the Twitter streaming API. And I took the text of each tweet. I'm filtering on all tweets that have Boston in it. I started running this a day or two ago. And I'm sending the text of each tweet to the Natural Language API. And then I'm storing the Natural Language API JSON response in BigQuery. BigQuery is Google Cloud's big data as a service tool. It lets you upload lots and lots of data and do analysis on your data. So I'm storing all that in BigQuery. And what I want to show you here is the BigQuery web UI. So this is my table where I'm storing all this data. We can see what my schema looks like here. And we can even preview it. So this is the text of the tweets. So these are just some of the tweets that are coming in. I'm getting the ID of the tweet, the text, when it was created, how many followers the user has. This is returned from the Twitter API. It just gives me a JSON response of all the hashtags in the tweet. And then we can see here I'm storing this giant JSON string of the Natural Language API response. And BigQuery lets you write SQL queries to query your data. So you might be wondering, how am I going to query this giant JSON string? Well, BigQuery has a feature called user-defined functions. I think Karthik talked about this in the previous presentation. This lets you write custom JavaScript functions that can be executed on columns in your table. So if I go to the next slide here, let's say I wanted to find the most tweeted adjectives associated with Boston. I can write this custom JavaScript function And this is going to be run on, actually forgot to show you how many tweets I've collected, about 70,000 tweets. So we're going to run this custom JavaScript function on all of the rows in our table. And this is running this function on all 70,000 tweets, which is kind of crazy. We'll see how long it takes. And there we go, it just finished. So what we're doing here is we're looking at the tokens and we're seeing if the part of speech tag is an adjective, we're going to return it, and then we're going to count the top adjectives. So these are all the adjectives we get for all of our Boston tweets. I've got another query here that I wanted to show you. I wanted to look at the hashtags returned from the Twitter API and see what the sentiment was by hashtag using the sentiment that we get from the natural language API. And we can see here that the sentiment isn't too strong for these tweets. It's looking like it's around 0.1. Nothing too crazy there. And the last query I wanted to show you was everyone loves emojis, at least I do. I wanted to see which emojis were the most common in these tweets. What were people using when they talk about Boston? And again, we're running this function on all the rows in our table. So we can see here that we have our Clover. I'm guessing maybe people are tweeting about the Celtics. I'm not a big sports person, so I could be wrong. And we could see all these other emojis that are being used to describe Boston. Got a baseball one here for the Red Sox. Lots of emojis. So that's just an example of how you could use the syntax annotation endpoint of the natural language API. I'm going to go back to the slides. So that was the natural language API, and the next thing I want to talk about is the translation API. So another thing you might want to do with text is translate it. You probably have users for your application all over the world, and you want to make your application accessible to them. The translation API essentially exposes the functionality of Google Translate to developers so that you can implement translation in your own apps. So first, let's take a look at Google Translate. So I'm guessing a lot of you have used Google Translate before. I use it all the time when I travel to countries where they don't speak a lot of English. So last year I was on a trip to Japan, and I really wanted to order some octopus. So I translated octopus. The word for octopus is taco, which is a little confusing to me, but I went with it, and I was able to order this delicious octopus, which you can see here. But you probably want to use translation for more than just translating the word octopus. You probably want to translate, many different pages throughout your app. And one company that's doing this is Airbnb. They're using the translation API to translate listings, reviews, and conversations for any people that don't speak the same language. So I was actually pretty surprised to discover that 60% of Airbnb bookings are between people that speak different languages in the app. And they found that using the translation API significantly improved a guest's likelihood to book. So calling the translation API is pretty self-explanatory. Here's a Python example of how you would do this. You just create a translation client, and then you pass it the phrase you'd like to translate and the language you'd like to translate it to, and it'll return the translation. The cool thing to note here is that I didn't have to tell it what language my source text was in. It was able to detect that this is English, and then it just goes ahead and translates it to Japanese for me. One improvement that we've introduced to the translation API recently is neural machine translation. And this greatly improves the quality of the translation. And essentially how it works is the previous model took each word separately and looked up the translation for each word. So this might be what you would do if you were traveling and had a dictionary with you and you wanted to translate a sentence. You might look up each word in the sentence, and your resulting translation would probably be enough to get by, but you might miss some nuances in the text. And so what this model is doing is it's looking at each word in the context of words before and after it, and it's able to produce a much higher quality translation. There's a good New York Times article about how it works. You can go to that bit.ly link on the slide to learn more. And just to show you some of the differences, I know there's a lot of text on this slide, but what I did was I took a paragraph from the first Harry Potter book in Spanish. So each translation of Harry Potter had someone that spoke the local language translating. Obviously, they didn't use an API to translate the books. That would not have gone very well. So somebody translated it into Spanish. So I took that Spanish text and translated it back to English using first-generation translation and then comparing that to neural machine translation. And I've highlighted the differences here. So we can see that we get improved quality. So instead of the verb made, we get more specific verb of manufactured, and almost twice longer than usual becomes almost twice as long as usual. So we just get some small improvements here, which end up making a big difference in the final quality of the translation. And the last API I want to talk to you about is our newest machine learning API, which is our Video Intelligence API, which lets you understand your video's entities at a shot, frame, or video level. One company that's using it is Cantemo. They're a media asset management company. So all of their customers are uploading lots and lots of video to the platform. Cantemo helps them transcode the video, and what they're using the Video API to do is help customers search within their large libraries of video. So the best way to see how this works is through a demo. So I'm going to hop on over here to my Video API demo. And what I've got here is a video of a Super Bowl commercial for Google Home. And I'm going to play the first few seconds of the video. So you can see there's a lot of scene changes happening here. I'm going to stop it now. I won't play the whole thing. But we saw, it switches from a mountain landscape to a dog, to a street scene, and we end in a garage. And if we were to manually classify this video, we'd have to watch the whole thing and write down what was happening in each scene, and then add those tags to a database somewhere. What we get with the Video API is it's able to tell us at a granular scene level what's happening in every scene of the video, and then at a high level, what is this video about? So if we scroll down here, we see what's returned in the JSON response from the Video API. It's able to tell us there's a dog, and it's even able to tell us where that dog is in the video. We can see that there's a birthday cake at the end. And if we scroll down, we can see it's able to identify the breed of dog that it is, and it's even able to identify that mountain pass from the opening scene. So that's what the API can do with one video. And what I want to show you is how powerful this can be if you've got a lot of videos in a database. So let's say you're a media company, you have lots and lots of videos, and you want to be able to create a highlight reel, selecting specific types of scenes from your videos and compiling them into one. So if I go to the homepage of my app, you can see that I've got quite a few videos here. Let's say that I'm a sports media company and I want to find all of my videos just of baseball because I want to create a highlight reel of them. So I can search my videos, and there we go. I can see not only which videos have baseball in them, but I can see where in the videos we have scenes of baseball. So this one is almost entirely about baseball. This is my favorite example. So this video, Google publishes a year-in search video every year highlighting the top searches, and we can see there's only a tiny portion of this video with a baseball clip. And so if we were to find this on our own, we may even miss it if we watch the whole thing. We might totally gloss over that baseball scene. But the Video API is able to find that scene for us. That's from last year when the Cubs won the World Series. So let's do one more search. Let's search for our beach videos. And we can see that, boom, the Video API is able to extract all of those beach scenes from our videos. And tell us exactly where the beach parts of the videos are, even if they're just a small portion of the video.
This year.
So that's what the Video API can do. Makes it really easy to search a large library of videos. And this is something that, even just a couple of months or a year ago may have taken a long time to do. Now you can do it just with an API call using the Video API. So I've got just a few more slides to wrap up. Some details on how this demo app works. I built it with Alex Wolf, so if you liked it, I can give him a shout out on Twitter. And this is an App Engine app. It's running on Google App Engine, which is our platform as a service tool. So the front end is built on App Engine using Node.js, and all of the videos are stored in a Google Cloud Storage bucket. And I've attached a Google Cloud function to that bucket. So whenever a new video is added, this JavaScript function is called, which takes the video and sends it to the Video API for processing. And one thing that you can pass into your Video API request is you can give it the URL of a cloud storage bucket where it should write the annotations. So I have a separate cloud storage bucket where I'm storing all of the JSON annotations. And the front end of my app engine app, isn't actually calling the video API directly. All it's doing is getting the videos from cloud storage, and then it's getting the associated video metadata from my other cloud storage bucket. So that's how the application works. And here's what the video API response looks like for an individual label. So here I have a video that's just a tour of the White House. In this particular scene, we have a bird's eye view, and it tells us the language of the label, and then it gives us this locations object with the start and end time in microseconds of every time we see that label occur. So if bird's eye view occurred more than once in a different part of the video, we'd get another segment object returned. And then we also get a confidence number of how confident is it that it correctly identified this part of the video. Here's another one where it identifies a portrait. And that's all I've got for the machine learning APIs. So I'll leave this slide up for a moment if you want to start using any of the ML APIs. I showed you the browser demos for a few of them. You can try them all out in the browser, including the video API. You can try it out with your own videos, or they've got some sample videos for you to inspect the response on.